Okay, in a past video we looked at how to find the area of an oblique triangle, that is how much two-dimensional space it takes up. But the fact was we had to know something first. We had to know two sides, okay, and their included angle. Now, in not every instance do we know two sides and their included angle. In certain instances we know three sides of a triangle. And so it is worth actually exposing ourselves to a particular formula called Heron's formula that allows us to solve for the area of a triangle as long as just all we know is all three sides. And so this particular formula, let's go ahead and take a look at it. As a matter of fact, it's good to just kind of take a look at it. We say that the area of any given triangle is defined as being the square root of this here. Now we got four numbers in here we're going to multiply. We say s minus lowercase a, s minus lowercase b, and s minus lowercase c. So we have s times s minus a, s minus b, and s minus c, where a, b, and c, what I want you to recognize are the three known sides of our triangle. And so in this particular case, what the heck does s represent? Well, when you look at this formula here, you'll notice that it says s is equal to a plus b plus c over 2. And so one thing we want to make sure we do is we refer to s as being the semi-perimeter. And semi just means half a perimeter. To use this formula, we're going to have to find s, which is our semi-perimeter. But it's a pretty neat formula. It just says as long as you know all three sides in the semi-perimeter, we can just find this square root of this product of these four numbers, and you have your area. And so I want to kind of practice using this here and talk about how convenient it naturally is. So looking at these two examples, the first one here, I don't actually have a diagram. And so we're going to go ahead and draw our own triangle here. I notice that all three of these side lengths are pretty close. So maybe I'll draw my triangle like this. But what I would know is that I have A, B, and C, where C is the longest. I would be inclined then to say that my longest side here is C. A is my shortest side, so I'd probably call this one here A. And then lowercase b, we could put this over here as being 12. So this would allow us to at least label out the rest of our triangle. Now we want to find the area of this. And so the first thing we're going to do is say, well, I already know all three sides here. What I'm going to need to find is S. So if A is 10 feet, and B is 12 feet, and C is 16 feet, then we get this. We get 10 feet plus 12 feet plus 16 feet all over 2, which comes out to be, and you know, let's get a calculator rocking here. Suppose 22 plus 16 is 28, but let's check it here. 10 plus 12 plus 16, 38. 38, not 28. 38 over 2. So our S here is half of 38, and I'm just going to go ahead and say 38 divided by 2. We'll get a decimal. It's no problem here. We say 19. So with these three side lengths and this semi-perimeter right here, the neat thing is we can just go ahead and say then the area is exactly equal to the square root of, and we're just going to plug all of these in. And so we get semi-perimeter, okay, 19. Not what I wanted to do. That's what I wanted to do. 19 times now s minus a, s minus b, s minus c. So when we say s minus a, we say 19 minus a is 10, okay. Here we're going to get 19 minus b, b is 12, so 19 minus 12. And then here we're going to get 19 minus c, which is 19 minus 16. Here's our area. And so I always recommend that we do actually go and simplify this. So we get 19. 19 minus 10, if we could at all do this, let's do it. We say 9. 19 minus 12 is 7, and 19 minus 16 is 3. So typing this into our calculator, we don't need to put all the parentheses. We just need to say the square root of, and we'll just go ahead and say 19 times 9 times 7 times 3, and end this parenthesis. As long as all of this is inside the square root, we get about 59.92. So we get about 59.92, and we want to make sure we label this with the proper units here. We say square feet. So 59.92 square feet is the amount of space two-dimensionally that this triangle takes up. Now in this last one here, this should look familiar. We just solved this triangle in the last example using the law of cosines, but let's say I want to find its area now. So again, as long as you know all three sides, we could just use Heron's formula. So we know A. As a matter of fact, let me take this out here. We'll say instead of A, we'll use X, Y, and Z. So we say X is 23, Y is equal to 25, and Z is our 26 here. So we're going to say, well, first of all, we want to solve for S. So S is 23 plus 25 plus 26 all over 2. Let's go ahead and get a value for this here. So we say 23 plus 25 plus 26. We get 74. So 74 halves that would be the same thing as, I believe, 37, but let's go ahead and check it out here. 74 divided by 2 is 37. So with our semi-perimeter now and these three initial side measurements, we get the area as being the square root of, okay, we would have 37, 37 minus 23, 37 minus 25, 37 minus 26, and cleaning this up a little bit here, we have the area then is 37 times, now 37 minus 23 would be 14, 37 minus 25 would be 12, and 37 minus 26 would be 11. So getting this all in the calculator now, we could go ahead and just type all this in. We say the square root of 37 times 14 times 12 times 11. We end up with this, about 261.49, 261.49, and this is in units squared. Okay, so that's Heron's formula in a nutshell, and it's pretty neat because it allows us with any triangle, as long as we know all three sides, to always be able to find how much two-dimensional space it occupies. Cheers.